Introductory Statistics. My name is Mark Ledbetter, and this is the video number 1. I'm going to introduce the study of statistics and then get started in Chapter 1, Part 1. In this video, we're going to introduce the study of statistics. I'm going to give you a brief outline of what we're going to cover this semester, and then we're going to dive into some basic vocabulary. So what is statistics? Well, I could give you the boring definition, which most books in the encyclopedias and dictionaries have. The science of collecting data, organizing data, summarizing, presenting, planning, performing experiments, analyzing data, interpreting results, drawing conclusions, and presenting data. Whew, I'm sleepy already. So what is statistics, though? The exciting version is it's being able to discover something about almost any population using a very small sample, at least relative to the whole population. And unlike physics, where you need to know the formula for gravity to talk about the gravity, or the formula E equals mc squared to talk about the transfer of mass to energy, or a formula for acceleration, velocity, etc. Then you use those formulas. But in statistics, we can study things that we have no clear idea of the underlying underlying equations or laws that govern that situation. So it's very powerful, and that is why I love statistics. Now, there are two areas in statistics that we sometimes divide the data in, the study of statistics into, especially in an introductory course. And we talk about descriptive statistics, and that's the organizing of data, summarizing it, maybe using a picture. But it's necessary to do this, but this is not by itself statistics, at least the way I think about it. So it's important to do this, and we'll find out that it's very important in Chapter 4. If you don't do this, descriptive statistics, then you could make an error when you get to the inferential side of things. So every good statistical analysis needs to include descriptive statistics, but that's not usually where we stop. So where we like to go usually is inferential statistics, and that's drawing conclusions about the population from a small sample. Okay, so let's look at an example. Let's say that our population includes all the people in Virginia that contracted the COVID-19 virus, and we want to study this. We want to know something about this. So what we do is we draw a random sample, which is fairly small. So we start randomly selecting individuals from that population, and that becomes our sample, which is the oval on the right side. We analyze that sample, we perform calculations, we use statistical techniques, and then we can draw conclusions about the whole population. So the catch here is that with statistics, there is always some level of uncertainty. We can never be 100%. But we can control how much uncertainty we have. It's very reasonable in many situations for us to be 99.9% confident in our results. We can get that close, but we can never get to 100. Okay? We need to walk before we can run, and so statistics is a very broad term. And I've listed out several areas of expertise within statistics, sub areas that people specialize in. And probability is one of those. And as an area of expertise is very mathematically involved and complex, but it's also referred to as the foundation of statistics. And it is the more basic principles of probability are required throughout statistics. So we don't have statistics without probability. I've listed out sampling theory. So all of the ones listed past sampling theory, and there are many more, require sampling theory in order to get or obtain good results, okay? And then we look at estimation and inference, and those are extensions of decision theory, and prediction and modeling. So all of these different areas of expertise